Okay, fine. So during the last lecture, we saw the reduction of order method. Okay, talking about reduction of order method, we have understood that if by some method, okay, we could find one of the solutions of the given homogeneous differential equation, then we can reduce the order of this differential equation by one. Okay, we did this for the second order, and today, if time permits, after doing the sums, I will also be doing it for the nth order. Okay, we'll be doing the reduction of order method for the nth order um, homogeneous differential equation, linear differential equations with variable coefficients. Okay, so last lecture we did it for the second order. We tried to understand that if we find one solution, अगर किसी भी method से एक solution ढूंढ लिया, तो second solution कैसे ढूंढना है? Okay, that's what we will have tried to find here. Okay. Just quickly taking you through this. Your general form should be y double dash plus p of q y dash plus q of p of x y dash plus q of x y equal to 0, where px and qx will be purely functions of x and the coefficient of y double dash should be 1. This is what you need to remember. We were learning how to find one of these solutions. So there are different options here. The solution could be of the form e raised to mx or x raised to m. Sine and cos is covered in the form of e raised to mx. And in that case, we've seen some conditions here. If 1 plus px plus qx is 0, then e raised to 1x will be the solution. And if 4 plus 2 times px plus qx is 0, then you'll have e raised to 2x as a solution and so on. On the other hand, we found x raised to m being one of the solutions. In that case, if px plus xqx is equal to 0, then you'll have x raised to 1, that is x itself is a solution. And if you have 2 plus 2x px plus x square qx equal to 0, then you will have y is equal to x square as the solution there. Okay, we saw some examples of the same category. Then we learned how to reduce the order. So suppose u is one of the solutions which we have already found. Then second solution अगर हम phi लेते हैं, so my general solution of y would be u times phi. Our aim is to find this phi, and we found the formula for phi over here. Okay, as okay, this is where we found phi here. Okay, and what I've written in the box is the value of y after we substitute the value of phi into it. So this is the method of finding the second solution of second order homogeneous linear differential equation with with variable coefficients. So let's begin with some questions over here or some sums over here. And if time permits, we'll go for the nth order reduction. Okay, reduction of order for the nth order. So let's look at some examples or sums. Okay. So these questions are taken from Codington book. The question says, a differential equation and a function phi 1 are given. Verify that phi 1 is a solution of the differential equation and find the second independent solution. ओके, सो यहाँ पे आपका काम इजी कर दिया गया है कोडिंग बुक में. एक सोल्यूशन दे दिया है ऑलरेडी. You are expected to find the second one and you have to verify that the one which is given to you is actually a solution. So the first example, x square y double dash minus 7xy dash plus 15y is equal to 0. Phi 1 of x over here is given to us as x cube. Okay, and it is said that x is greater than 0. Okay, how will you start with this question? Come on. How will you start with this question?
Divided by x square.
Sorry.
Divided by x square.
ओके, पहले तो डिफरेंशियल इक्वेशन को एक्स स्क्वायर से डिवाइड कर देते हैं। तो मेरे पास 7/x हो जाएगा यहाँ पे एंड 15/x स्क्वायर हो जाएगा। ठीक है, ओके, ये हो गया। ये आपका डिफरेंशियल इक्वेशन इन द स्टैंडर्ड फॉर्म आ गया। उसके बाद
px एंड qx लिखेंगे।
अच्छा, पहले तो एक चीज याद रखो, यहाँ पे आपको फाइव वन सोल्यूशन है ये बताना है पहले तो। ठीक है, तो पहले तो फाइव वन सोल्यूशन है ये चेक कर लो। दो चीज है ना यहाँ पे, वेरीफाई फाइव वन इज अ सोल्यूशन एंड सेकंड चीज है आपको फाइव टू ढूंढना है, मतलब दूसरा सोल्यूशन ढूंढना है। ओके, तो फाइव वन
Let
सोल्यूशन है ये
y
कैसे?
is equal to phi 1, then find y dash, y double dash and put the given equation.
Correct. So you can start with phi 1, which is x cube, then phi 1 dash, which will be 3x square, and phi 1 double dash. ठीक है ना, y नहीं assume करोगे तो भी चलेगा। चलो, let us put it as an equation number 1, left hand side. LHS of equation number 1 क्या हो जाएगा? y double dash मतलब phi double dash यानी 6x minus 7 upon x into y dash is 3x square. Okay, plus 15 times y would be x cube. Okay, so let's simplify this. This is going to be 6x. Okay, and I think there is a 15 upon x square. Yeah.
मैम आपकी स्क्रीन नहीं दिख रही है।
स्क्रीन दिखाई नहीं दे रही है।
यस मैम।
Screen is visible. Sarfaraz, you leave and join again. बाकी लोगों को दिखाई दे रही है, if I'm not wrong.
यस मैम, इट्स विजिबल।
सरफराज, आपके एंड पे नेटवर्क का इशू है, प्लीज चेक करिए। ओके, फाइन। Minus 21x plus this is going to be 15x. So this is going to be 0 and Sarfaraz, please stay on mute. Okay, therefore we claim that phi 1 is a solution. Phi 1 is a solution. Now, can you find phi 2 on your own? Come on, class. Give it a try. The formula is here. And apply the formula, tell me the answer. Apply the formula, tell me the answer. Anyone got the answer?
cx raised to 6 upon 3.
सी एक्स रेज टू 6/3 आ रहा है कि एक्स रेज टू 5 आ रहा है परीन? Anyone else? Yes, please.
Yes, ma'am, cx is to 5 upon.
Okay. What about other people? Let's look at the solution. इतना टाइम नहीं लगना चाहिए. चलो ये जो फॉर्मूला है इसमें पहले तो मुझे चाहिए e रेज टू नेगेटिव इंटीग्रल ऑफ p dx. इसको अलग से कैलकुलेट कर लेते हैं. आपकी जो p की वैल्यू है, ओके लेट मी एक्सपांड द स्क्रीन. ओके हियर. सो आई विल सॉल्व इट ऑन दिस साइड सो दैट आपके पास सोल्यूशन और ये दोनों साथ में विजिबल होगा. सो यहाँ पे अगर देखोगे तो p ऑफ x फ्रॉम इक्वेशन नंबर 1, p of x is a coefficient of y dash, तो -7/x आ जाएगा. Your formula is having e raised to negative integral of px dx. So let's substitute the value there. I would now get this is equal to e raised to positive हो जाएगा ये negative negative मिला के 7/x dx. So this is nothing but e raised to 7 log x. अब 7 log x is nothing but log x raised to 7. E and log will get cancelled. You will be left with x raised to 7. This is the value of the integral. Okay. Now coming to the value of y. Coming to the value of y. By the formula, y is equal to c times u. Integral of this integral which we have found here. E raised to negative integral p of x dx. Divided by u square dx. अब यहाँ पे u क्या होता है? The first solution which we have. आपको क्वेश्चन में u दे दिया है. Okay. The first solution is x cube दे दिया है. So c times x cube इंटीग्रल ऑफ न्यूमरेटर में आएगा x रेज टू 7, डिनोमिनेटर में x क्यूब का स्क्वायर मतलब x रेज टू 6 आ जाएगा. सो दिस विल नाउ बिकम c टाइम्स x क्यूब और इंटीग्रेशन में बचेगा सिर्फ x. सो इंटीग्रेशन में जो x बचा है उसका इंटीग्रल होगा x स्क्वायर बाय 2. सो द कॉन्स्टेंट्स कैन बी कंबाइन. इसको c1 बोल सकते हैं, इसको x रेज टू 5. दिस इज योर सेकेंड सोल्यूशन. So first solution was x cube and second solution is x raised to 5. ये आपके दो अलग अलग सोल्यूशन हो गए. बोथ ऑफ दीज सोल्यूशंस आर लीनियरली इंडिपेंडेंट. चेक करना है तो आप चेक कर सकते हो. लीनियर इंडिपेंडेंस इसका कैसे चेक करोगे आप? ब्रॉन्स्किन कैलकुलेट करोगे. फर्स्ट सोल्यूशन का x क्यूब है, सेकंड सोल्यूशन आपका x रेज टू 5 है. इसका ब्रॉन्स्किन है सॉरी डेरिवेटिव आएगा 3x स्क्वायर, यहाँ पे 5x रेज टू 4. क्रॉस मल्टीप्लाई करोगे तो यू विल गेट 5x रेज टू 7 minus 3x raised to 7, which is 2x raised to 7. This is non-zero. I can claim this because question has very clearly said over here that x is greater than 0. X is not equal to 0 बहुत clearly बोल दिया है. Okay? So this Wronskian is non-zero and therefore the solutions are independent. I hope this is clear with everyone.
Yes, ma'am.
Okay? So this is what we have done here. And this is how you solve for the second order. This is how you solve for the second order. Okay. Uh, one more thing to note over here in this particular question is that ये जो question है ये आपका कॉशी फॉर्म में है, कॉशी यूलर इक्वेशन के फॉर्म में है. कॉशी यूलर इक्वेशन आपके सिलेबस में नहीं है, बट अगर उसके सॉल्यूशंस ढूंढोगे तो आपको थोड़ा और समझ में आ जाएगा. ठीक है, एक और क्वेश्चन ट्राई करते हैं, लास्ट वन इस कैटेगरी में, बिकॉज ये टाइप के सम्स तो अभी आपको समझ में आ चुके हैं एंड नॉट वेरी डिफिकल्ट, इंटीग्रेशन ही अप्लाई करना है आपको. ओके, एक और ट्राई करते हैं, देन वील मूव ऑन टू द nth ऑर्डर रिडक्शन ऑफ ऑर्डर मेथड. वील ट्राई वन मोर लास्ट क्वेश्चन. ओके, क्वेश्चन नंबर 2. The main question will remain the same. एक solution दिया होगा, you'll have to check whether it is the solution and you'll have to find the second linearly independent solution. So your y double dash minus 4xy dash plus 4x square minus 2. Okay, let me equal to 0. First solution is given to you as e raised to x square. E raised to x square. Okay. So begin by verifying that phi 1 is a solution and try to find the second solution. Begin by the verification step and find the second solution. And I think 5 minutes should be enough time to try both verification and solution by. Could you verify that 5n is a solution?
Yes, ma'am.
Okay, good. Calculation of phi 2. Calculate phi 2. Anyone with the answer? फाइव इज अ सोल्यूशन किस किसका वेरीफाई हो गया? thumbs up करो. Okay, Ankita has completed. Nisha, okay, good. Raj has completed. What about other people? चलो solution discuss करें. Let's discuss the solution. Yes, please. Or you'll manage on your own. Yes, students, you want me to discuss or we'll move to the next one? I haven't received any answer for 5-2 yet. Okay, ठीक है. चलो. 5-1 is a solution prove करना है तो we'll have to start with the derivative. 5-1 is e raised to x square. 5-1 का डेरिवेटिव एक्सपोनेंशियल का डेरिवेटिव एक्सपोनेंशियल ही होता है, but then x की जगह पे जो टर्म है उसके डेरिवेटिव से मल्टीप्लाई करेंगे, चेन रूल अप्लाई करेंगे तो x स्क्वायर का डेरिवेटिव 2x. सो 2x e raised to x स्क्वायर आ जाएगा. 5-1 डैश. 5-1 डबल डैश uv रूल लगेगा. u as it is. Derivative of e raised to x square is e raised to x square into 2x again. Plus e raised to x square as it is. Derivative of x is 1. On simplifying, this becomes 4x square e raised to x square plus 2 e raised to x square. We found the values of phi 1, phi 2, phi 1, phi 1 dash, and phi 1 double dash. Okay, you found these three values. Let's substitute them in the equation here. So, LHS of the differential equation, after substituting, I'll get 4x square e raised to x square plus 2 e raised to x square in place of phi double dash minus 4x times y dash would be phi dash, that is 2x e raised to x square plus 4x square minus 2 as it is, y की जगह पे e raised to x square. Let's open the brackets. This term as it is, this term as it is. This is negative 8x square e raised to x square. This is plus 4x square e raised to x square and negative 2 e raised to x square. So here negative 2 and positive 2, this gets cancelled. This and this gets added to 8 and minus 8 is going to give me a 0. So that's your RHS. That's your RHS. And therefore, okay, 1 minute. This is not responding. Yeah. Therefore, I can claim phi 1 is a solution. Okay. So we found one of these solutions. Now we move to the second solution, that is say maybe phi 2. To find phi 2, I will first calculate e raised to negative integral of p of x dx. And in this particular case, the value of p of x is negative 4x. So negative negative will become positive. So I'll have integral of 4x dx. Okay. So when we integrate this, we'll be left with 4 times x square by 2, which is nothing but e raised to 2x square. Okay, let's now substitute this value in the formula for y. So the formula for y is c times u, integral of this integral which we just found, divided by u square dx. Now if I want, I can replace this u square with pi 1. Okay, because we have pi 1 as the first answer. Okay, and let's substitute the values here. So c is a constant, phi 1 is e raised to x square, integral of 2x square, and denominator e raised to x square the whole square. I'll continue this side. C e raised to x square, numerator is 2x square, denominator is e raised to x square into e raised to x square. So that is nothing but 2x square again, if you can calculate that. So I'm left with integral of 1, and integral of 1 is nothing but x. So this is your second answer, you can say. Okay, this is your required second answer. Or your second solution is x over here. Okay, so this is again going to be linearly independent. You can check it using the Wronskian method. I hope the concept is clear now. No difficulties. Yes, students.
Yes, ma'am, understood.
Ankita,
Yes,
if you
ma'am.
understand. Ankita, you were not audible. Okay, fine. So the concept of reduction of order for the second order is clear with everyone. Okay, we will look at the nth order. Okay, what happens when it comes to nth order? And of course, that is also a part of your syllabus. Fine. So let's look at that. We're looking at reduction of order itself, but this time it is nth order homogeneous linear ODE with variable coefficients. Okay. So let's start with the basic assumption. So let's say we have this L of y is the required ODE, which has nth order derivative plus a1 of x n minus 1th order derivative plus a2 of x n minus 2th order derivative, and you will have an minus 1 of x with y dash and an of x with y. And because it is homogeneous, this is going to be equal to 0. Let me call this as equation number 1. Okay. So let's see. Again, we will have one of the solutions which is already found. Okay. So you would say, let u be a solution of equation number 1. So what are we going to do is we'll reduce it to n minus 1th order. nth order से n minus 1th order पे लेके आएंगे. फिर n minus 1th order का अगर मेथड है तो पता है तो ठीक है. अदरवाइज वहां पे भी एक सोल्यूशन ढूंढ के एक और ऑर्डर डिक्रीज करते करते we will be able to come to a point where we will be able to solve it. That is what we are claiming here. एक एक ऑर्डर रिड्यूस करते जा रहे हैं. ठीक है. Okay. So of equation number 1, we try to find the solution phi of equation 1 such that this phi is equal to u times phi 1. Okay. So this solution, as we had claimed before, y is equal to u times phi. यहाँ पे you are claiming phi is equal to u times phi 1. Okay. So let's say because phi is a solution of L of y, it satisfies the equation. It satisfies the equation. So I'll now have u phi 1 nth order derivative a1x u phi 1 n minus 1th order derivative,
Screen is not visible.
not visible. It is visible. Students, I don't know. You can put this message in chat and maybe other students can reply so that the link is not broken. Okay? Because there'll be other students who might be, responding as well. And then maybe it could be your end network issue. That also happens. So if you find such issue, you can just put up a message in the chat so that others can respond to it. If it is a problem with everyone, then yes, you can unmute yourself and discuss maybe with me as well. Okay. And this entire thing will be equal to 0. Okay. So now let's understand how do we find the derivative here. We'll be using the Leibniz rule to find the nth order derivative. So the first term, of course, remains u, and you will have the nth order derivative here. And then you have n times u dash and phi 1 n minus 1th order derivative. N minus 1 divided by 2 u double dash phi 1 with n minus 2th order derivative. And this will continue till you reach your, okay, I started with, okay, till you reach the nth order derivative of u and phi 1 remaining as it is. Okay, this is using Leibniz rule. So those of you who do not remember Leibniz rule, you can just revise it for yourself. Okay. And here you can exchange. U and phi 1 can be exchanged. Not an issue. Okay. Next we will have A1. Again, it will start with n minus 1th order derivative. So suppose it starts with u here, phi, and this will go on up to n minus 1th order derivative of phi with u as it is. Okay. Then we will have A2 and so on, proceeding in the same manner. Just a minute. So it is, okay. Proceeding in the same manner, we will come to an minus 1, which is having only phi dash. So you have to apply UV rule. So u derivative of v and v derivative of u. And an will remain as it is. This is going to be equal to 0. Okay, fine. So let's look at the coefficient of u now, only the coefficients of u. So when I look at the coefficients of u, the first one is here. The next coefficient of u is here. Okay, with A1 of course. And then you have the next coefficient of U is here, and next coefficient of U is here. So when I look at these coefficients only of U, and I forgot to mention, okay, 1 minute. Okay, so this is phi 1. This is also phi 1. So I forgot to put that 1 there. So you can see U1 has all the phi 1 raised to n, A1 times phi 1 raised to n minus 1. So you will actually get U common, and you will get L of phi 1. Okay, which we know is going to be 0. Correct? Which we know is going to be 0. So this, and you will have other terms, and you will say this is equal to 0. Since phi 1 is a solution, we say that L of phi 1 is going to be 0, and therefore the term of U is going to vanish. The term of U is going to vanish. Okay, what we will be left with is powers of U dash, U dash, U double dash, and so on. Agree? Yes, please. And up to the nth order. Okay, so we're left with this. So what do we do again? As we did in the second order, we replace U dash as V. So this implies U double dash will be V dash, and so on. So this is what we are doing, reduction of the order. We are reducing the order now. Okay. So now let's see what are we left with. The first one, I'll be left with n times V phi 1 n minus 1th order, n minus 1 by 2. All the highlighted terms are all out, okay? They're all out with 0. U double dash will be replaced by V dash, and phi 1 of order n minus 2. Un will be replaced by n minus 1 for V and phi 1 as it is. Then you will have A1
Screen is not visible, ma'am.
not visible. 1 minute. Actually, the program cannot take a lot of annotations when it's now getting hanged.
मैम
I can't see the screen yet.
मैम मैम बीच बीच में स्क्रीन हट जा रहा है और फिर आ रहा है ऐसा बार बार हो रहा है
अच्छा, वो आई थिंक वो जब मेरा यहाँ पे अटक रहा है ना, मैं जब भी पेन सिलेक्ट करने की या चेंज करने की कोशिश करती हूँ, तो वहां पे मुझे ऐसा हो रहा है कि वो अटक जा रहा है, एंड आप लोगों को शायद विजिबल नहीं हो रहा है, ऐसा हो रहा है. Because for me it is working, but at the same time it is going on pause. It is not, I'm not able to select anything there. ऐसा हो रहा है. ठीक है, I'll just close it once and restart it. Give me 1 minute. I hope now it shouldn't be a problem. Is it visible now?
यस मैम
Yes, ma'am.
Okay. And I hope the software doesn't gives me trouble now. Okay. So let's see where were we. Yeah, we raised to n minus 2, phi 1, and you will be having an minus 1, phi 1 times b. This is equal to 0. So now what has happened here is, okay, we got a linear or homogeneous equation, ordinary differential equation, where the order for V is n minus 1 maximum. Okay, the order is reduced. nth order से n minus 1th order पे आ चुका है ये. Also, let's observe that the coefficient of n minus 1, v raised to n minus 1 is phi 1. The coefficient of v raised to n minus 1 is phi 1. And here, phi 1 will be non-zero because we are interested in the non-trivial solutions. Phi 1 was one of these solutions, right? Okay. So here, the coefficient of v raised to n minus 1 is phi 1, where phi 1 is not equal to 0. Phi 1 is not equal to 0. So what are we going to do over here is that we will find, therefore, now this linear differential equation of order n minus 1 will have n minus 1 linearly independent solutions. Okay, let us call them as, say, v2, v3 up to vn. These are n minus 1 solutions. And this will be on the interval I where the differential equation is defined. So for x naught belonging to I, some x naught, okay, some point in the interval, we will now define uk of x as integral x naught to x vk. How could we define this? What was our assumption for v? V was equal to u dash, right? So if I'm able to find v, हमने एक order reduce कर दिया है. तो अगर थर्ड ऑर्डर है तो उसको हम सेकंड पे लेके आए हैं और सेकंड का मेथड यूज करके हमने दो इंडिपेंडेंट सॉल्यूशंस निकाल लिए हैं. ठीक है. तो अब u जो ढूंढना है, जो मल्टीपल है फाई का, फाई 1 का, to find that u, you will integrate that answer. Are you understanding this? So whatever n minus 1 solutions you might get here, okay, you will have to integrate them from a particular standard point up to x, which is a variable, and you will then find the corresponding u's over here. And those u's along with phi 1 will give you the n solutions of the linear differential equation which we started off with. I hope you're understanding. Is this okay? This is basically, see, this is not going to be a concrete formula we won't get. जैसे second order के लिए आया था वैसा नहीं मिलेगा because second से we move down to first and first के हमारे पास methods हैं. ठीक है, we are dealing right now in general. So we're just going to work in general and we're going to write general things, okay? So then I can claim uk dash is vk, okay? And the functions phi 1, u2 times phi 1, u3 times phi 1, and un times phi 1 are the n linearly independent solutions of L of y equal to 0. Of L of y equal to 0. Okay? And rather, we would actually try to prove this is linearly independent here. We will like to prove these are linearly independent. So we'll say these are the solutions and we will prove. Okay, we claim that these phi 1, u2 phi 1, u3 phi 1, un phi 1 are linearly independent. So how do you start with the linear independence? We start with the definition. We consider C1 phi 1, C2 U2 phi 1, C3 U3 phi 1, Cn Un phi 1. This is equal to 0. Now, since phi 1 is not equal to 0, I can divide by phi 1. I'll have C1, C2 U2, C3 U3, Cn Un is 0. I have to prove these are linearly independent. अब ये prove करने के लिए we will use the fact that UK dash is VK and we already know that V2 से लेकर Vn are linearly independent. Okay, this is what we know already. So you will use this fact, and to use this particular fact, we are going to take the derivative here. So let's take the derivative. So C1 ka derivative 0, C2 will become U2 dash, C3 U3 dash, Cn Un dash. So C2 U2 dash will be replaced by V2, V3, and Vn. Now if I consider this, since V2, V3, Vn are linearly independent, I can say that C2 is equal to C3 is equal to Cn is equal to 0. And if these are 0, and I put them back in, say, equation number 2, if I'm not wrong, I will get C1 is also 0. Because C1 plus 0 is equal to 0 aa raha hai, right? So this implies phi 1, U2 phi 2, sorry, U2 phi 1, U3 phi 1, and Un phi 1 are all linearly independent. So one thing I want you guys to understand here is, unlike जो हमने कल किया था, okay, वहां पे क्या हो रहा था, you found an actual concrete formula. You could find the actual concrete formula. यहाँ पे we are not finding concrete formula. This is just a general technique which says that if you have one solution, you can reduce the order by one. If you have two solutions, you will be able to reduce the order by two, and so on. And when you reduce the order, okay, when you reduce the order, what is going to happen is every time when you reduce the order, you might come to a degree where you will be able to solve it on your own. I hope this is clear with everyone. Yes, please. Okay, this is a little general thing, but yes, if you check your syllabus, reduction of order is given in nth order unit also, and it is given in the second order unit also. So I've done it for both of it, and I've taken it together. So ये जो topic है, ये actually दोनों units में overlap हो रहा था, ऐसा मैंने साथ में लिया है. Okay, I've not done it unit wise. I hope that is fine with everyone. Okay.
मैम
So
ये कौन से यूनिट में?
nth order वाला जो topic है, ये आपका होगा unit number 1 में, if I'm not wrong. Yeah. nth order आपका जो है वो unit number 1 में है, और जो हमने कल किया था सेकेंड ऑर्डर वाला वो यूनिट नंबर 3 में है. दोनों में रिडक्शन ऑफ ऑर्डर मेथड है. यूनिट नंबर 3 में ऑर्डर 2 है, और ये जो अभी किया हमने वो यूनिट नंबर 1 में है. इज दिस फाइन? ओके,
Yes, ma'am.
फाइन.
यस मैम.
So next lecture I'll let you know when I can conduct the lecture. As
मैम
I
तो
told,
एग्जाम में जो है तो हमको लाइक how do we prepare by should we prepare by unit wise or should we prepare by the concept that you have taught? And
see, questions will be asked unit wise. Concept clarity is what you require, right?
yes,
So If the question is asked for nth order, you will have to, of course, you'll have to prepare for both. You don't know which question is going to come in the exam, whether it's going to be the nth order or
Right.
it's going to be second order. So you need to prepare for both.
But 10th other का कोई एग्जांपल्स नहीं आएगा because
nth order के
ये
examples है. I was just coming to that. कि नेक्स्ट लेक्चर जब भी होगा आई विल टेक सम एग्जांपल्स ऑफ nth ऑर्डर. वहां पे हम रिड्यूस करेंगे उसको सेकंड, मतलब जनरली आपके पास थर्ड ऑर्डर के क्वेश्चंस है, तो आप थर्ड को सेकंड में कन्वर्ट करोगे एंड सेकंड के जो मेथड्स है उसको यूज करके आप उसको सिंप्लीफाई करोगे.
ओके.
ठीक है, तो वो जो एग्जांपल्स है वो मैं नेक्स्ट लेक्चर में लेने वाली हूँ. एंड एग्जाम्पल नहीं भी रहा, अगर पूछा नहीं गया, थ्योरम सिर्फ अकेले पूछ सकते हैं ना वहाँ पे.
राइट.
ओके, सो दैट इज ऑल्सो पॉसिबल. तो 10 मार्क्स के आपके पास थ्योरम वाला पार्ट भी तो है ऑप्शन वहाँ पे पूछने का, तो दैट
और
कैन
मैम
बी आस्क्ड. या
जो टाइम टेबल है वो मतलब उसमें कोई बीच में गैप्स रहेगा कोई एग्जाम मतलब इसके लिए सिर्फ कोई भी सब्जेक्ट के लिए एक दिन
जनरली
का एक
हो
दिन
जनरली होना चाहिए. Okay, so let the timetable come. I feel there should be some gap.
दो पेपर के बीच में.
Yeah, there should be, but then I will not be the right person to comment on this. The correct authorities will be like, the people managing from IDOL itself.
ओके.
Okay, so you can
होपफुली.
please,
मैम
yes, please.
मैम 26 नवंबर को जो लेक्चर हुआ था मैम उसके नोट्स नहीं है.
Last दो lectures के ना
कोलाई
मैंने,
लेमा वाले. हाँ यस मैम यस मैम.
हाँ मैं अपलोड कर देती हूँ एक्चुअली. हाँ, थोड़ा सा मैंने जैसे बोला ना, मेरा स्केड्यूल थोड़ा सा टाइट चल रहा है, तो उसमें मैं इसलिए 1 1 आवर का ही लेक्चर ले पा रही हूँ. मैं वो लेक्चर लेने के बाद ना ऐसे थोड़ा घाई घाई हो रहा है मेरा, तो आई डू इट. या
एक इंटरनल का भी पूछना था मैम क्योंकि हमारा कॉम्प्लेक्स का इंटरनल हो गया है और डिस्क्रीट का इंटरनल हो गया है.
हाँ.
तो बाकी सब जो यूनिट सब्जेक्ट तीनों सब्जेक्ट है उसका सिर्फ एक एक इंटरनल हुआ है.
Okay,
तो
not an
उसके लिए
issue. नहीं, not an issue. We will schedule it maybe 1 week before the exam itself, so that आपके लिए भी वो थोड़ा fresh रहेगा ना तुरंत. वो भी एक हो सकता है.
ओके.
Okay. Chanchal, you're asking something? Chanchal, आप यहाँ पे कुछ पूछ रहे हो? Okay, fine. So we'll stop here today, and next lecture we'll take few examples of third order जिसको हम reduce करेंगे second order में, and then reduction of order वाला topic complete हो जाता है. मेरे एंड से अभी मेजर आपके यहाँ पे स्टर्म लिवॉयल थ्योरम बाकी रहेगा, पिकार्ड्स मेथड बाकी रहेगा, एंड सिस्टम ऑफ ऑर्डिनरी डिफरेंशियल इक्वेशन. ये 3 टॉपिक्स बाकी रहेंगे. So I think I'll require not more than 6 hours to complete that. So 3 more lectures and I should be able to complete with your syllabus. But somewhere around 60 to 80% of syllabus मैंने touch किया है. Okay, in these lectures. So that should be helpful to you guys. Go through your syllabus, check the proofs, check the what do you say, sums based on these topics. Okay, so that you're kind of prepared. I definitely will not say that I've touched all the 100% of your syllabus, but then at least 60%, 70% to touch हुआ ही हुआ है. Okay, so that is the thing. Fine, so we'll stop
मैम
here. Yeah.
लाइक हमने अभी तब जो थ्योरम्स किए तो हम इतने थ्योरम्स करेंगे तो क्या एग्जाम के लिए काफी होगा? थ्योरम्स
हमने अभी तक
प्रॉब्लम्स
जितने
है.
थ्योरम्स किए हैं वो यूनिट नंबर 1 2 एंड 3 में वेरी हो रहे हैं. ठीक है,
यस
and yes,
मैम.
I'll be doing unit number 4 also. So that should be kind of sufficient. And आप एक बार syllabus को हमेशा, you should always keep syllabus. मैं बोलती हूँ वो उसका आपको है ना, गीता है आपकी, वो कुरान है आपका, या आपकी बाइबल है, वो आपका syllabus कॉपी होना चाहिए. तो वो जो syllabus कॉपी है उसके अंदर जितने टॉपिक्स है वो सारे आपके कवर हो जाने चाहिए. बिकॉज अगर कोई भी पेपर सेटर हो, कहाँ का भी, उसने अगर पेपर सेट करके भेजा, वो सिलेबस के बाहर के क्वेश्चंस नहीं डाल सकते हैं. सिलेबस के बाहर के क्वेश्चन अगर वो डालते हैं तो आप उस पे क्लेम करके मार्क्स मिल सकते हैं. तो सिलेबस के बाहर के क्वेश्चंस कोई नहीं डालता है, आपको सिलेबस को ही फॉलो करना है. आर यू अंडरस्टैंडिंग?
यस मैम.
Okay, and I'm trying to follow the standard books which are referred in your syllabus. Those 2 books which I have been telling you are Codington, दोनों Codington के ही books हैं. एक है Theory of Ordinary Differential Equation और दूसरा है Basics of Ordinary Differential Equation. I'm trying to cover up things from those books. And again, as I said, I am able to cover only 60 to 70%, not 100%. Okay, so these are the two standard reference books which are mentioned even in your syllabus. So I have tried to take up as many theorems which are there in those books. Again, उसके अलावा भी थोड़े और theorems but related to your topics हो सकता है, possible है. Is this fine?
Yes, ma'am.
Ma'am,
Yes.
ma'am, where can I get these notes of regular lecture?
The lectures which we are
Hello.
conducting, I am uploading them on the Eclipse. Like last 2 lecture के हुए नहीं है upload और आज का ये
On
तीसरा.
Moodle, ma'am.
Yeah, on Moodle, yes. Moodle में
Okay.
upload हो चुके हैं. पहले के notes upload हो चुके हैं. सिर्फ
Okay,
3
ma'am.
lectures के बाकी हैं वहाँ पे डालना. ठीक है?
Okay, ma'am.
एंड ये एक बार अपलोड करने के बाद मैं एक मैसेज डाल दूंगी आपके ग्रुप में. सो यू विल कम टू नो दैट यू आर एक्सपेक्टेड टू check Moodle and your notes are available there. I'll try to do it within this week itself so that things will be available. Okay, thank you, class. You can leave, please.
Okay,
Thank you, ma'am.